we start our class. Rabi, hello Rabi. Yeah, Rabi. Today I need you till the last, okay? Look, all these learning outcomes are done except these three, J, K, L. Huh? All learning outcomes we discussed. All the recordings are available. Yesterday, yeah, that was not yesterday, day before yesterday, right? We had class. We discussed all the things related to evaporation. So this part is completely over, and from this part we have only JKL. Now we are going to discuss those things from the notes. The notes already I uploaded today's meeting invitation you got, right? In the Google Classroom. Hello. Hello everyone. Ravi, the Google Classroom, you got the invitation.
Yes, sir.
There I uploaded this notes. This note is not available in your book. These three learning outcomes here.
Sir, Ravi is not in the class.
Okay, Ravi again disconnected.
Sir, Ravi is not available, sir.
Okay,
Sir,
Ravi is
it's
there. Ravi is
having
there.
problem.
Okay, there is network problem. I understand. Now, look here. We have this notes. I made it, and I followed the learning outcomes mentioned here when I prepared. This one is not available in your book, okay? That's why I gave you the notes, okay? So everyone, you understand?
Sir, you gave the notes in the Google Classroom of this page.
Yes, yes.
Okay, sir.
Today I send you the invitation. There you will get it attached. Okay?
Oh, okay, sir. And then where is the exam, sir?
Exam will be 31st after 11 days.
31st.
Yes.
Okay, sir.
So from now on, you get prepared. Read all the notes from your book and this one, and learn everything. Go through the recordings. Inshallah, I will be able to do everything in the test. Okay. We are done with this topic, and only these three things are left. So we are now discussing thermal expansion of solids, liquids, and gases. So Saad, you read. Saad.
Yes, sir.
Hmm.
Thermal expansion of solids, liquids, and gases. All three sets of matter, solid, liquid, and gas, expand when heated. The atoms themselves do not expand, but the volume they take up does. When a solid is heated, its atoms vibrate faster about their fixed positions. The relative uh, the relative increases in the size of solids when heated is therefore small. Metal railway tracks have small gaps so that when the sun heats them, the tracks expand in these gaps and does not buckle.
Okay, wait here. We got here a very important thing. In your MCQ part, you'll get these questions several times. That molecules or atoms, they are not expanding. What is expanding? The solid in a whole, the solid is expanding, right? Like you are getting one block of iron. There are lots of molecules over there. Their vibration increases, right? That's why they expand.
Yes, sir.
The volume increases, but the molecules or atoms, they don't increase, right? Is it clear?
No, yes, sir.
Molecules, atoms,
Sir, I have confusions.
they are not expanding. In between them, the gap that is increasing.
It's expand. Yes, sir.
Is it clear? That's why the whole thing you are seeing that is expanding. Is it clear now?
Yes, sir. But sir, the relative
Yes.
increase in the size of solids when heated is therefore small. Sir, what this means?
It is also because of the vibrations of the molecules. Vibrations, because of the vibrations, there is molecules, they are having some you know gap between them, right? Little bit more.
Yes, sir.
It's not like liquid or gas, but there is little bit gap increases. That's why their volume increases. If there is only two molecules or two atoms, there is very small uh, increase. But if there is millions, then because of small, it increases little bit, right? Is it clear?
Yes, sir.
Okay,
Yes,
now
sir.
Aisha joined, right? Hello, Aisha. Now look here, metal railway tracks. You know about railway tracks, right? Here we have the joint of two bars, and in between the joint there is a gap. Why we keep this gap? So that they are not during the summer or during the hot. That time the metals are expanding. If we are not keeping this gap, then they may overlap to each other, right? And they may bend. When they are trying to overlap each other, then they will bend. If they are bending, then there will be accident, right? The train cannot go properly, right? There will be derailment of the bogies of the train. Is it clear?
Yes, sir.
So that's why we are keeping some gaps to avoid the accident.
So I didn't also to avoid the accident.
Yeah. If there is the overlapping of these bars to each other or it's bending, then train cannot go properly, right? There will be
Oh, okay,
accident,
yes, sir.
derailment of the train from the line.
Okay,
Now
sir.
next one, we have expansion in liquids. Hmm. Ravi, you read. Ravi, can you read please?
Yes, sir. Liquids expand for the same reason, but because the bonds between separate molecules are usually less tight, they expand more than solids. This is the principle behind liquid in glass thermometers. An increase in temperature results in the expansion of the liquid, which means it rises up the glass.
Okay,
Molecules between
so you know about the thermometers, right? That we are using liquid in glass thermometers, that is mercury thermometer or alcohol thermometer, where the expansion of liquid is working, right, to get the readings, isn't it?
Yes,
Hello.
sir.
So here we are using expansion of liquids uh, to have some measurements or to get the measurements in thermometer. So it is one of the benefits that liquids are increasing and we can use them for our daily life needs. Is it clear?
Yes,
Hello?
yeah,
sir.
Okay. Now continue. Rabi,
okay,
continue on this part.
yes, the molecules within gases are further apart and weakly attracted to each other. Heat causes the molecules to move faster. Heat energy is converted to kinetic energy, which means that the volume of a gas increases more than the volume of a solid or liquid.
The recording is going on, right?
Yes, sir.
Yes, sir. According.
Okay. Okay. Thank you. So here you understand that molecules, they are more expanding, right, than the liquids and solids, and their kinetic energy increases. And if you think of hot air balloon, yeah, this one, this is using the expansion of liquids, yeah, expansion of gases, right? Because of the heat supplied, the volume of the gas inside it increases. If the volume increases, that means density decreases, right? Hello,
Yes, sir.
you know the formula of density. Density equals mass
Mass by
over
what?
volume. The the gas amount of gas inside it is same, so mass is same, but the volume increases. That's why the overall density of the balloon, hot air balloon, is decreases. You know that one thing, if it is becoming less denser, then it rises up, isn't it? Hello,
Yes, sir. Yes, sir.
can you remember this? That if anything is becoming less denser, then it is rising up, and by rising up, we can enjoy the beautiful landscape of the surrounding area using the
So
hot air
those are
balloon.
helium gas, right?
Uh, we
In
are
the
using
balloon.
helium gas mainly. There might be, even if we are not using the helium gas, we can use only air also, right? The air particles, those are also inside its fixed, right? Hello,
Yes,
Yes,
sir.
sir.
yeah. So then air particles inside it, if it is expanding, that means outside air that is still with the same density, but inside air that is becoming less denser, so it will float. Is it clear now?
Yes,
Yes,
sir.
sir.
Okay. Then the last part, you please read, Rabi, about the
In
gases.
hot air, balloon density decreases as volume increases of the same amount of gas. Mass same. Hence, balloon rises up and we can enjoy beautiful landscape. However, gases that are contained in a fixed volume cannot expand, and so increases in temperature result in increase in pressure.
This one we discussed in last class, right? That if the volume is fixed, this one we have increasing the volume, right? That's why we are having less denser. Uh, and here, if the container is sealed, container is not open, that time we are having more pressure. We discussed in last class. You can get they who are absent, they can get the recordings, and you can go through the recordings to understand that. So is it clear, everyone? So,
Yes, sir.
and here we are getting some more examples about thermal expansion. Uh, and now we are going to learning outcomes again. Look, we already got described qualitatively the thermal expansion of solids, liquids, and gases. Describe the relative order of magnitude of the expansion of solids, liquids, and gases. Then list and explain some of the everyday applications and consequences of thermal expansion. So we understood all these things from here, right? We
Yes, sir.
understood even their magnitude of increasing. Solids are expanding least, then liquids a little bit more, and gases are most, right, expanding most. And we are having some more examples. In breeze you are getting this type of things, right? Gap, small gap, low,
Yes, sir.
and this is also for avoiding the hazard of thermal expansion. uh, the down part of it like this, okay, so that there is rollers are there so that it can move forward and backward easily. And here we are showing another one, that is bimetallic strip. It is used in iron, in our iron. When in my house also the iron is available, uh, we are controlling the temperature of the iron, right, with a knob over there. And the place we fix over there, if the temperature is too much, then the light off, isn't it? The iron stops taking the more heat or more current. The bimetallic strip is helping for this, to do this purpose. We will discuss now how it is working. Okay, now this one, Shafkat, can you read this part? Yeah, the bridges one. Some more examples of consequences of thermal
Some more
expansion.
examples of consequences of thermal expansion. The expansion of solids may damage the bridges and roads as they are constantly subjected to temperature changes. Bridges made of steel girders also expand during the day and contract during the night. They will bend if their ends are fixed. To allow thermal girder rest on rollers in the gap left for expansion.
So is it clear? Are these things very tough or very easy? Very easy to understand, right? So
Yes, sir. Very easy, sir.
very easy to understand. Very simple thing. Now bimetallic strip. Yeah. First I explain it, then you read, you'll understand. Look, here we are having bimetal. That means we have two, plates of metal. One is iron made, another one is brass. So they have some property like brass, iron. Their expansion is different. The way brass is expanding, iron is expanding less. The same amount of heat supplied. So here we are getting heat energy. That time the brass is expanding more and iron is expanding less. That's why there will be some bending. Okay, the way brass is bending, that way the iron is not bending. That's why there is bending. You understand it? Hello, hello, students.
Yes,
Are
sir.
you understanding what I'm saying?
Sir, can you
Yes.
repeat this portion, sir?
Okay, I'm repeating it. Look, brass is expanding more, okay, and iron is expanding less. This is the property of these metals, okay, because
Yes, sir.
Yes,
the
sir.
molecular bonding is reason that iron is expanding less and brass is expanding more for the same heat given. So for this reason, for this property, what happens if we are giving heat to this bimetal, then there is bending, right? As the brass is expanding more, but that way the iron is not expanding. That's why there is bending. This much you understood?
Yes, sir.
Okay.
Yes.
Then we are having one switch here. Uh, like in iron, we have a switch here uh, connected with this one. Then when it is here, then electricity can go, right? The wire is connected with the circuit. Okay. When this is in this position, the brass is in this position, the iron is in this position, then electricity can go and it can become heated. Is it clear?
Yes, sir.
Hello?
What, sir? You understood this part?
Yeah, we have a circuit, right? And this this is wire. Okay, this wire is connected to the brass so that electricity can come and the circuit is complete.
Oh, okay, sir. Okay, sir.
Is it clear now?
Yes, sir.
Okay, now when it is bending, that time what happens is going up, then circuit is incomplete. That's why you know that when it is more hot, that time the switch is becoming off and you are not getting the iron, that iron you are doing for clothes, right? Ironing. You understand? For clothes, we are doing ironing, right? Hello? In house you did any time? Saw any time in your house you have iron for clothes?
Yeah, I think
Yeah,
so.
yeah. So in our house, I
Sir,
do
for what?
for clothing for your clothes to do the ironing.
Oh, yes. Yes, sir.
Okay,
Yes.
yes. So that one when it is going up, that is the switch is not working, right? And the circuit is incomplete. So it will not become more hot. Is it clear now?
Yes, sir.
So So this way the bimetallic strip is controlling the iron. If there is too much hot, then the switch is off automatically because of this bimetallic strip. Then our clothes is not burning. Is it clear? Hello? All of you are
Yes, sir.
clear. So this one,
Yes, sir.
whatever I discussed here is written here over here. Then Aisha, you read. Aisha, please read this part.
A bimetal, a BS metal strip
Bimetal, say bimetal. Huh?
okay. A bimetal strip consists of two thin strips of different metals, such as brass and iron, joined together. On heating the strip, the brass expands more than iron. This unequal expansion causes the blending of the strip. The bimetal, the bimetal strips are used for various purposes. Bimetal thermometers are used to measure temperature, especially in furnaces and ovens. Bimetal strips are used in thermometers, bimetal
Thermostats. Thermostats.
thermostats. A, a bimetal thermostat is used to control the temperature of the heater coil in an electric iron.
So this much is done, right? We discussed, you understood, and
Yes.
you understood the use of bimetallic strips. So here is written what is thermostat again. Can you read this part also?
Thermostats. The thermostat is a heat regulating device which works on the principle of thermal expansion.
So bimetallic strip is one kind of thermostat. We have also thermostat in air conditioner. You can check the window AC we are having. There is also written in the knob one place that is thermostat. Okay, you can check in your house if your house have window AC. So there we are also controlling the temperature, right? In AC, that it will be 18 degrees Celsius or 20 degrees Celsius or 22 degrees Celsius. Do you know that? Hello, AC, air condition. I'm talking about air condition.
Yes, sir.
Yeah, so the same way it is used over there. That one, this one is working with heating, but the AC, that one is working with cooling. Okay, there will be bending in opposite side. Because of the cooling, there will be contraction, right? Here we are getting expansion. So in contraction, the bending will be in opposite side. That is also thermostat. So we are done with thermal expansion of solids, liquids, and gases, right? We are done with all the contents. The contents, learning outcomes we have in
Sir, thermostat also can bend. You told at the last.
yeah. Which one?
Okay, okay, sir. No, the thermostat.
Yeah,
It
it
can
is the
also
last.
bend.
It is the last. Yeah, it is the last,
Okay,
and
sir.
it will also working bending, right? This is also
Yes,
thermostat.
sir.
This is also thermostat. The bimetallic strip, it is also called thermostat. Okay.
Oh, okay, okay, sir. Yes.
Another name is thermostat because it's working with uh, therm or heat. That's why it is called thermostat. Okay, we can go to the worksheet, right? Then, hello.
Yes, sir.
Okay, this is your worksheet. Today again I uploaded. I uploaded it before. Again today I uploaded in today's invitation. So you can so that you can have it easily. You do not need to go scroll back and go back. Okay, is it clear, everyone? Hello. And in last class, I told you to try the worksheet. How many of you tried? Hello.
Only Saad.
Yes, sir.
Only Saad. What about Shafkat? Shafkat,
Yes, sir.
you did not
I
try?
didn't write, sir. No,
You
sir.
didn't try. So when you will try? Tomorrow?
Today, sir. Sir, today, sir, today.
Today you will try, inshallah. And I will upload the mark scheme also. Okay. MCQ part, the mark scheme I will upload. You try and check your one is correct or not. That will help you to go faster. Is it okay? Will it be good for you if I upload the mark scheme?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So you continue, Shafkat. Read this one, the first one. Shafkat, read. First one, read loudly.
Oh, sir, it was muted, sir. Some gas is trapped in a closed container. The gas is cooled and the volume of the container is kept constant. What happens to the gas molecules? Cool.
Okay, if it is heated, then what happens?
Sir,
Then the
it
gas
will
will,
like sir
they will move
contract with the
faster.
wall. Then they will move faster. Yeah,
Yeah,
collide
Yeah,
with
I
the
think
wall more often.
yeah. If they are heated, then they are getting faster, right?
Yes, sir.
And if they are cooled, what will happen?
Sir, I think condensation
They
will
will be,
happen and the particle will get close together or move slowly.
so which one
I
is
think the D, sir.
more appropriate?
The D, sir. They
Sir,
move more slowly.
then D, sir, but it could
They
also be
move
C.
more. They move more slowly. You see, one thing you should take notes. Okay, in your copy you should take the notes. Uh, Here the answer is D.
What's the answer is D.
Yes, they move more
But
slowly.
why, sir?
Yeah,
Yes, sir. I also said D.
it is cooled, right? If it is
Yes, sir.
heated, they are having more kinetic energy. But if they are
Yes,
cooled, then they will have less kinetic energy. That's why they are
yes.
moving slowly. Is
But sir,
it
they
clear?
also can turn into liquid
Yes.
as condensation will occur.
If they are reaching to that much cold, their freezing point that time, or their condensation point that time. Is it clear? Then they will state the change.
Okay, sir.
Yes, sir.
Now, what about this? What they are asking you, what happens to the gas molecules? Look, they are asking about the molecules. Just now we got the idea, molecules can never contract. Are you are you clear why it is not contract?
Yes, sir. They cannot
Okay,
contract.
No, sir.
okay. Then another
They
thing
can
is given
contract.
here. Uh,
Sir,
Molecules cannot contract. The gas can contract.
Yes,
Is it
sir. Yes.
clear? They are
sir, why
asking
the
about
molecules cannot contract, sir?
molecules structure. Atom. They are in nucleus and in the shell, right? The electrons. Their their size will be fixed. Okay, only the gap between them, their intermolecular force or their bonding, there will be change. But they are inside the atom, inside the elements, there will be no change. Is it clear now? To
Yes, sir.
change
Yes,
it,
sir.
we need nuclear reactions. Without nuclear reactions, it cannot be changed. Is it clear now?
Yes, sir.
Yes, sir.
Okay. And now, why we are not taking A or C? You should write this on your copy. They get close together. When they get close together, if
When it is called to the freezing point.
look, the volume, the volume of the container is kept constant. If you are decreasing the volume, then the molecules are getting closer, right? Then pressure will increase. If you are
Yes.
if you are decreasing the volume, then molecules are becoming closer to each other, right? Because they are not getting any space to go far apart, isn't it? Then
Yes.
they will collide with the walls more often. So these two options will be only applicable if the volume is decreases. Okay, for these two it is happening only if V decreases. You take these notes, please. On your copy, you take these notes. These are very important. If you understand it, then you can solve the questions coming forward, similar ideas, with similar ideas. So is it clear, everyone? This question is clear, all the points? Hello? Hello?
Yes, sir.
Okay.
Yes, sir. Sir, 2 will be C. No, sorry, B. D.
Wait.
C,
It
sir.
will be
2D.
B or C, we will discuss later. First, let Shafkat to read the question. Shafkat, read.
Okay. The diagram shows four changes of state W, X, Y, and Z. Then there's a diagram. Which row gives the names of the four changes of state?
Yeah.
So should I read the option?
Very easy, sir.
You do not need to read all the options. You just think for a while. 1
Sir,
minute
D,
you
sir.
think,
Sir,
then
I
you
thought,
tell
sir.
me the
D,
answer.
sir. So D,
Dhaka,
Sir,
Dhaka,
yes,
sir.
sir. Dhaka, Dhaka, D.
Dhaka.
100%.
Can you explain this one how it is D?
Sir, it's the process, sir. Gas to liquid will be a condensation, which represent X, and
Okay.
W is.
Yes. Very good. Yeah. Then continue.
So similarly, then liquid to gas will be evaporation or boiling. Since there is no evaporation, boiling is given, so we will choose that one. And for Y, the solid to liquid is obviously melting, and liquid to solid is freezing.
Excellent. So everyone understood the explanation.
Yes,
I
sir.
think
Yes,
I
sir.
think
Yes, sir.
he explained nicely. So the answer is D here, right? Dhaka.
Yes, sir. Dhaka.
Now we are going to next one. Question 3. Yeah, continue this.
Uh,
3.
what increase what increases when a liquid becomes a gas as its boiling point? The average kinetic energy of the molecules, the molecular size, the molecular spacing, the total number of molecules.
What increases? Molecular size will not increase, right?
Yes, sir.
Then total number of molecules will not increase, right? Isn't it?
Sir,
Yes,
I
Yes,
sir.
sir.
think A.
Then what increases?
Sir, I think A.
I think A, sir. A, sir, I think.
The average kinetic energy of the molecules.
But also the molecular spacing also increases, sir.
Molecular spacing increases. Look, here we have confusion with this one, A and C, right? B and D, we
Yes,
are confident that they will not be the answer.
yes, sir.
Now, in between A and C, which one is more appropriate? That one we'll choose. Look,
I
here
think
the first one is said the average kinetic energy of the molecules in the difference of boiling and evaporation. You got this idea, right? That the temperature remains constant everywhere in boiling. Can you remember that one? Hello?
yes, sir.
Yes,
For
sir.
evaporation, it changes, but
Yeah. In
for boiling, I think.
evaporation, the more energetic molecules are there, less energetic molecules are there. But in boiling, we
Yes,
have
sir.
all the molecules, they have average kinetic energy same, right?
Yes, sir. Yes.
Okay, in boiling process. Now that is confirm that is the molecular spacing increases, right? As the molecular space increases, that's why it's turning to gas from liquid, isn't it? You know the property of liquids and gases, right? Distinguishing properties that molecules move farther apart, right? In gas. Can you remember the distinguishing properties we learned from the book?
Yes, sir.
So which one we should choose?
C.
Sir,
C.
C, sir.
C
Molecular.
is most appropriate. So we are picking C. C is our correct answer. Now we are going to another one. Question number 4. Yeah. Continue this. Afkat,
A
continue.
metal, yes, sir, yes, sir. A metal lid fits tightly on a glass jar. Which process makes it easier to remove the lid from the jar? A. Cool the lid only. B. Put the jar and lid in a refrigerator. C. Warm the jar only. D. Warm the lid only.
Okay, so here we are getting two things. One is metal, another one is glass, right? Glass jar and metal lid, right? And it was
Yes, sir.
tight. So which one will help you? Which process or which activity will help you to remove the lid from the jar? If you are cooling the lid, then what will happen? The lid will be contracting, right? It will be more tight, isn't it? Hello?
Yes, sir.
Yes, sir.
It will be more tight. You cannot even remove it or you cannot move it. Then B, put the jar and lid in a refrigerator. If you are doing it, then both will be contracted. Again, they will be more tighter, right? And
Yes, sir.
then we have warm the jar only. Then jar, if you warm the jar only, then what will happen? Jar will expand, but the lid will not expand. Then again more tight,
Sir,
isn't
D.
it?
Sir, D is the correct.
And then final one, warm the lid only. Then expansion in liquid, expansion in lid only. That one will make it easier to open, right? There is no expansion in the glass jar. Only lid is expanding. Then it is loose, right? Isn't it? You
Yes,
can
sir.
open it easily. So the answer is D. And it is related to
Sir, I have
expansion
a
of.
question. Sir, I have a confusion, sir.
Uh,
Sir, in the question is, sir, which process makes it easier to remove the lid from the jar? Sir, if
yeah.
it expands, then it will be harder for us to remove, sir.
No, the lid will be expanding. That means the lid is becoming loose.